On this spot, in the 12th century, the Cistercian monks founded an abbey. The monks withdrew, and for centuries Stanlow remained, bleak and lonely. Now the marsh has vanished, for in the years following the Second World War, there has been rising here one of the larger oil refineries in the modern world to feed and foster the working strength of 20th century Britain.
It was March 1948 that we kicked off, with a series of meetings between the engineers and contractors to line up the work. The chief construction engineer took the chair. The site of the new refinery lay close to the existing installations at Stanlow and the chemical plant, about a mile south of the Manchester Ship Canal. Further west, where the Ship Canal joins the Mersey at Eastham, the Canal Company were making their contribution to the project. They were building the largest oil dock in the world, large enough to berth 4 28,000-ton super tankers at once. The cooling water, very important in refinery operations, was to be pumped in through lines from the Ship Canal. After circulating through the plants, it would be cooled down again in a giant concrete tower before going back to the canal. The building of this tower alone would be a sizable job. We planned to tackle the work in 4 stages, from early 1948 to late 1951. Stage 1, December 1949, would see the first distillation unit ready. Its function was to split up crude oil into petrol and fuel oils, and so help to relieve the petrol shortage. Stage 2, July 1950, would see the completion of the reformer for improving the quality of the petrol. Then, in the 3rd stage, we were to build a second and much larger distillation unit and have it running by June 1951. Last, the catalytic cracking plant, the cat cracker for getting more and better petrol, was to come on stream at the end of the 4th stage in December 51. As we went along, we were to connect up the new installations with the existing refinery and the chemical plant, so that when it was finished, the whole layout would work as a single unit, making a wider range of petroleum products than any other in Europe. And the job at its peak would require a labor force of 4,000 men. By the spring of 49, we were pretty well underway. Before we could set the main lines for the cooling water to and from the canal, we had to blast away hundreds of tons of rock and sandstone. We used sheet piling to support the sides of the trenches for the water lines, then circular reinforcement for the lines themselves. They'd be 8 feet in diameter and nearly 1.5 miles long. There was a hill between the Ship Canal and the refinery, and to bring the water lines under it, the civils had to bore over 1 mile of tunnel. First, they sank an 80-foot shaft straight down into the middle of the hill. Then they started tunneling, outwards in both directions from the shaft bottom and inwards from each end. By summer, the base of the cooling tower was nearly ready. A huge, reinforced concrete raft, 260 feet across. At the same time, we were working ahead, pouring the concrete for the other plants as well. In the case of the foundations for the cat cracker, which would have to take an enormous weight, the great thing was to get the concrete to set as a single mass, a solid lump, so to speak. So we just went on and on without stopping. Round the clock and round again. 1,000 cubic yards in 24 hours. For some time, they'd been putting up the really big cranes. Derricks, they're called. The largest were 200 feet high and could lift about 75 tons apiece. Then, before we knew it, the scaffolding for the cooling tower was going up. A great circular silver web in the autumn sky. All this time, the pipe that we would need later on was coming in. Hundreds of miles of it. And it went on coming in too, all through the job. Now those plates, like flower petals, are the beginnings of the gas storage tanks. Horton spheres, we call them. They form segments to which other curved plates will be welded, so as to make a complete globe. This is how things looked towards the end of '49. Steel going up everywhere. Riveters chattering from one end of the site to the other. The parts of the jigsaw were beginning to fit. Soon the towers of Distillation 1 were pushing their way up through the maze, and in November it was going on stream. That meant we'd finished the first stage on time, and less than a year later, petrol came off the ration. Round about Christmas time of '49, about a third of the shell of the cooling tower was up, and getting higher every day. the new year, the welders were busy on the oil storage tanks, rows and rows of them. When they were finished, the whole lot together would hold over 500,000 tons of crude oil and manufactured products. And over there, across the site, you could see the framework of the cat cracker climbing up into the air. Meanwhile, the tunneling crews had been drilling their way through that hill. And now the borings for the waterline had almost met. It was a cold March morning up above when they blew the last barriers. Now the tunnel ran all the way through the hill, right from the refinery to the site of the intake pump house on the banks of the ship canal. We'd scheduled the reformer for July 1950, but actually it was ready long before that in April. And so we finished stage 2, nearly 3 months ahead of ourselves. With distillation 1 and the reformer both finished on time, we could sit back for a moment and look round. Roads and pipe tracks were beginning to crisscross the site. And beyond, distillation 2 and the cat cracker were coming along very nicely. And now we were off on stage 3, the longest pull of the lot, because it meant a great deal of special construction and chemical engineering. They say that in olden times, this whole area was a bog, with a monastery somewhere in the middle. I wonder what the monks would have made of all this. Away down the ship canal at Eastham, the oil dock was taking shape. To bring the crude oil from the tankers, which would berth there, to the refinery, we had to put down a 7-mile pipeline. At one place, we had to take the pipeline under the canal. And this is how we did it, all in one piece. It was just about then that they poured the last barrowful of concrete into the wall of the cooling tower, 340 feet above the ground. And now they could start taking down the scaffolding from the inside. 115 miles of it, enough to stretch clear across England from Stanlow to the Wash. Do you remember the spring and summer of 1950? It rained cats and dogs, day in, day out. The damp seemed to go right through you and out the other side. How did we manage? Oh, well, we just squelched on. There was a tricky bit of work came up just about then. The water lines from the canal to the refinery had to be taken onto the main railway tracks from Warrington to Ellesmere Port. We'd shored the tracks up on temporary steel girders while we were cutting the ground away from under them. And now we had the job of replacing the girders by permanent concrete beams. There was so much traffic that British Railways would only let us interrupt it for 24 hours at a weekend. So we tackled the job one Saturday night at 10:30. By 5:30 next morning, we'd got the girders out. And at dawn, the railway people sent in a crane to set the concrete beams. And believe it or not, by 6 o'clock on Sunday evening, the job was done. We'd lifted the tracks, pulled out the girders, set the beams, and put back the permanent way. All in 19.5 hours. Ah, what a weekend that was. Of course, they got canteens all over the place. But there's nothing like a new-laid egg gently fried in a shovel. By the middle of 1950, the fittings of the cooling tower were going in. It's a beautiful bit of work. The feed from which the water to be cooled would flow formed a central hub. And from it would radiate nearly 3,000 tons of concrete beams and pillars. All the time, great columns and vessels like these kept coming in from factories all over the country. Quite a sight it was sometimes, you know, and I must say everyone took the traffic hold-ups very well. And now it was autumn 1950, and they were getting down to the innards of distillation 2. The battery of 3 heaters was going in. They were hanging the hooks to support the thousands of yards of pipe inside. Bringing in more than 70,000 fire bricks to line the walls. And then came the winter, and it began to snow, and then it hailed, and then it froze. My goodness, it was cold work sloshing about in the icy water down in the intake pump house. Early in 51, February it was, the cooling tower was pretty nearly finished. And they were fitting the last of some 800 miles of wooden louvers, over which the water would pour on its downward journey from the feed in the center. The weather had looked up a bit by now, so we made an all-out effort to get distillation 2 finished on time. These are bubble caps. They're bolted to steel trays in the fractionating columns, and they help to separate the lighter from the heavier products. For example, petrol from fuel and lubricating oils. And each column may hold upwards of 80 trays, one above the other. Then, in that summer of 1951, came one of the spectacular jobs. The gas separator unit was ready to be lifted up into place. It was 170 feet long and weighed 240 tons. And there she is, up on end and sitting pretty. That'll be worth a pint in the local tonight. But you know, that was only one of lift after lift that had been going on all over the site almost since we started. Some of us spent most of that year down below ground in the tunnel. In the spring, they did the final inspection of the water lines from the canal and got them ready. On April the 9th, we let the water into the cooling tower for the first time. And now you can see the principle of it. When the refinery is working fully, the warm water from the various plants, 18,000 tons of it every hour, will all be collected here at the top of the center feed. Then it'll flow outwards through the radiating pipes to be sprayed from these sprinklers, down in a mist of fine droplets over the louvers, being cooled as it goes by the updraft of air caused by the shape of the tower. So we were able to bring the big second distillation unit on stream, again ahead of time. And now for the last lap, stage 4, the cat cracker. The vessels for it, regenerator, catalyst hoppers and so on, had been assembled on the spot. Now we were lifting them into place. Putting in the cat cracker's control instruments was a long and patient business. When a cracker's at work, you've got to keep a pretty tight eye on the flow and temperature in its different parts. In spite of its enormous size, it's a very delicately balanced piece of equipment. That's why all these hundreds of gauges are needed, with all their circuits and switches and valves and relays. And then the painters were in, swarming over the columns and spheres. And I don't mind telling you, we'd put a tremendous amount of work into the whole job. 110,000 tons of steel, 250,000 cubic yards of concrete, 10 miles of roadway, enough pipe, it seemed, to stretch from one end of the globe to the other. And nearly 4 years of hard work, rain, shine, or snow. Early in 1952, we handed over the cat cracker to the operators, watched them bring it on the stream. I remember it very well. We'd no time for speeches just then, but we shook hands all round. And I think at that moment, we felt a deeper satisfaction than any fine words could say.
The oil we need to serve our effort and expansion here in Britain is flowing in now from the further reaches of the globe, and especially from the great fields of the Middle East. And now as well, from wherever it may come, we have the means to manufacture it, to bend this ancient energy of earth and sea and time to the purposes of our endeavor. Here, on this corner of the Cheshire Plain, something has been added to the stature and the future strength of Great Britain.